All right. Okay. So, hello, dears. So, welcome to yet another pre-recorded lecture in your clinical bacteriology class, and this is the last pre-recorded lecture for our bacteriology class. No, medyo emotional ako, no. Medyo nasasenti na ako, Lige. For pila ka months, I've been doing this, recording here in the research room. Na ako sa, and trying to discuss the topics. Imagining imagining that there are students listening to me, and yeah, it's quite sentimental and medyo emotional. Char, wala jud ano. But yeah, so again, this is our last last pre-recorded lecture in your clinical bacteriology class, and for this lecture, we're going to talk about applied bacteriology. Okay, so when you say applied bacteriology, so you're applying, bacteriology, or like we're studying bacteriology that's outside of the clinical specimens that we receive from our patients. No, so we examine other specimens that are not necessarily coming from the body. Okay, and for this part, what we're going to talk about is mostly water bacteriology, and short lang yun about milk bacteriology. Gamay lang yun kaayo. Mga usara ka or duara ka slides on milk bacteriology. Just an overview. All right. And water bacteriology, actually, it's quite a review on what you had in your public health last year, in your second year. Yeah, it's more on that, and we'll expound on that and introduce other methods. All right. But supposed to be, there's also a food bacteriology, like we detect organisms that may cause food-borne illnesses, okay, or those that can cause food poisoning and all that. But this part of bacteriology or microbiology kanang applied, it's usually reserved na jud for other fields of study like food technology kanang ana. So as medtechs, we are only limited to detecting bacteriology or applying bacteriology sa water, okay, and even to a degree sa milk, all right, but mostly sa water, all right. So we'll focus more on water bacteriology here, okay. All right, so ayan, so this is our last lecture na gyud together, so medyo sentimental pero laban lang ta. Char. Okay, all right. So an introduction to water bacteriology. Of course, your water is a vital component to all of us, a vital necessity for all human beings, not only even human beings, but all living things. It's considered to be, again, the universal solvent, di ba? Recall in your mga basic sciences ninyo, in your earth sci, yes, water is the universal solvent. It can dissolve anything, char, okay? But aside from, or although it is considered to be vital for our existence, no? It can serve as a vehicle or a vector or a place for contamination or for transmission of diseases, all right? So it can serve as a vehicle for the transmission of different microorganisms that can cause disease to humans and even animals. That is why it is imperative, or it is important that we talk about, okay, water bacteriology, okay? So this is now where bacteriology comes into the picture. Because again, water can serve as a vehicle to transport or transmit different microorganisms. So it's our role now as medtechs, okay, to determine if the water source of a particular community or a particular place is safe to drink, or is it potable, okay? All right, ayan. So again, according to our favorite vlogger, drink your water, toot, okay? Drink your water, toot, okay, ayan. Always drink your water, guys, and stay hydrated. All right. Okay, now for water bacteria, what are some diseases that may be attributed to contaminated water? Of course, first is typhoid fever, and second is cholera. Now, these are just some of the diseases, all right? If you recall in your parasitology, of course, there are other parasites that you may get from contaminated water. You have Giardia, the amoeba, no, and all the other parasites. Okay, so for bacterial infections, what we get from contaminated water are usually typhoid fever, of course, from causative agent of Salmonella enterica typhi, and also cholera, Vibrio cholerae. So it's usually those diseases, again, among others, na pwede ito makuha from contaminated water. Okay, all right. Now we go to the bulk of the procedure on how or what do we test in water bacte. For water bacteriology, again, as mentioned po sa inyong public health last year, water bacteriology is focusing more on detecting indicator organisms, okay, rather than the pathogens. Because again, you are in the premise that water may contain a lot of other organisms, not only those that come from humans, na contaminate from humans, but also from those that are coming from the environment, from the animals, okay? So what we detect are indicator organisms, all right? And if we detect those indicator organisms, then we can say, or then we can also say, or it's also tantamount to saying that in a way, that water may contain the pathogens, all right? Or that the water that you are drinking may be unsafe for people to drink. All right? Okay, so these are the criteria for indicator organisms. First, dapat these organisms are consistently present. So, dapat consistent, no? So, dili siya para sa imong X. So, imong X, dili pa ding indicator organism. Ow, charot. Okay. All right, so, first is again, dapat it's consistently present in human feces in substantial number. All right, so, kitsa man na. Okay, number 2, it can survive in water at least as well as the pathogenic organisms or longer. So, pwede siya makasurvive sa water. And last is detectable by simple tests. Now, taking into all of these criteria, so that's why ato ang indicator organisms are your coliforms. Okay, now your coliforms, again, later we will know, but usually your coliforms are usually the enterics nato, okay? But the coliforms, manggod, are a general term. Okay, it can encompass or it can include all of the bacteria regardless of source, gikan ba siya sa human, sa plants, or sa soil, that can ferment lactose and mannitol. Okay, so therefore, muna siya ito ang indicator organism. Alright? Because they are usually the primary indicators that potentially harmful bacteria may be present. True enough, because again, di ba, your salmonella, your vibrio, they are non-enteric mga there are pathogens that may cause enteric diseases, di ba? Alright, and the presence again of coliforms may indicate also that the pathogens are also present there, okay? Because in a way, most of the pathogens that cause diseases, they're also mga lactose fermenters, or they are also coming from the enteric system of humans or even animals, all right? Okay, ayan. So these are coliforms. Okay. Again, there are two major tests that we perform for water. Number one is the MTFT, or multiple tube fermentation test, which you have experienced again in your public health, pero medyo gi-modify lang to siya. Wala tani padayon until sa last, no? And another one is the heterotrophic plate count. This is a new one, I believe. We'll discuss that later. And the last one is, joke, yun pala. So, MTFT and heterotrophic plate count. Sa heterotrophic plate count, di ang naay different mga procedures. Alright. But the general two ways yun na itong gina-perform is ang multiple tube fermentation test and heterotrophic plate count. Sa SOTO, personally, naay water analysis na section, tapad sa microbiology na section. And they test water. And I think what they do is, or what they use is the multiple tube fermentation test. Yes. All right. So yes, legit ni guys. It's happening in real life. Okay. All right. So we now follow what we call your MPN. Now, the most probable number, meaning the most probable number or the density of bacteria, probable density of bacteria na naa sa imuhang sample. All right. So again, it is otherwise known as the multiple tube fermentation test, or the test for total coliforms. You estimate again the total or concentration of viable organisms by tenfold dilution, meaning from tenfold, from a dilution of 10, mahimong 1, mahimong 0.1. So, imo siyang divide by 10. Tenfold. Alright? Okay. And it's usually used, di ba, if kabante mo, it's not only used in water but also in soils, agricultural products, and those samples that may contain particulate material. So, kana mga naay mga soil or na mga particulate material that may include mga feces from humans, mga inana. Alright? That interferes with plate count enumeration methods. Because again, particulate matters. These are kana mga contaminants, alright, from the soil and ana, na if imo siyang i-plate, pwede siyang maka-hinder kay naay laing mutubo outside of the sample. Alright? Okay. Ayan. And again, it's used to determine the presence of a member of the coliform group in groundwater and surface water. Again, coliforms are a general term. Okay, it's not only referring to your normal flora sa enterics or the enterics. Coliforms may include also the bacteria that come from the soil, from the environment, from other sources. Basta dili lang humans. But again, there are still gram-negative bacilli that may ferment. Okay, that ferment lactose and mannitol. Okay, and ano lang yun is, and among the coliforms, E. coli, of course, Escherichia coli is the most predominant fecal coliform that is causing diseases or that may cause that may cause disease to humans. All right, or yeah, it's the most predominant fecal coliform that may exist in the sample. Okay, all right. Ayan. Okay, basta ang point is coliforms are a general term, okay, for lactose fermenters na gram-negative bacilli, non-spore formers, okay, or non-spore forming. And again, they may come from other sources, not only from humans, pwede siya from the soil, from the environment, from plants, from animals, di ba? So, and ang predominant good na fecal coliform, meaning katong coliforms na gikan sa feces, alright, is E. coli. Alright, so that's why, in a way, muna siya itong indicator organism. Okay, so we focus on that. Alright, okay. Ayan. Now, again, the test consists of 3 stages, di ba? Recall in your public health, you have the presumptive, the confirmatory, and then finally the completed test or stage. Alright? And your test designs may be in 3 test designs po. Number 1 is you have your water sample. You divide that into 3 setups, and each setup contains 5 tubes. Okay? So, meaning 15 ka tubes imong gamiton. Alright? And ang imong sample first is 10 ml, okay? So first nimo is 10 ml, and then next is 1 ml. So 10-fold dilution pa rin. So 10 ml, 1 ml, and then last is 0.1 ml. 5 tubes. So 15 ka tubes na nimong gamiton. As another design is pwede still the same, the sample divided into 3 setups, and each setup contains 3 test tubes. So 9 raka test tubes imong gamiton. Still the same volume, basta 10-fold gyapon, 10 ml ang first setup, followed by 1 ml, and then finally 0.1 ml. And last, which is usually what we will do unta if natay lab class in person, is 10 ml to 5 tubes lang. Okay? Alright. But again, it's much more preferable that you use a lot of tubes or a higher number of tubes to increase sensitivity. Ayan. So, mas higher ang sensitivity or mas taas ang sensitivity if you use a lot of tubes. Of course, because you detect much more, okay? Kay you distribute man to a lot of tubes. So, pwedeng ma-include yung tanang mga kagaw na dito, bahala, samot na if in low concentrations, okay? So, mas taas ang sensitivity. Alright? But in our lab class, supposed to be, what will follow is this. Kanirang sample to 10 ml. The water sample nimo, tapos kuha kang 10 ml each, mong ibutang sa 5 ka test tubes. Okay. So, 10 ml each to 5 test tubes. Okay. Alright. Ayan, now we go now to the different stages. Alright, so first one is of course the presumptive test. Now for the presumptive test, dili pa siya, in a way, pwedeng dili pa siya pang specific yun. So it detects all lactose fermenters, regardless kung fecal coliform ba siya, asa siya gikan na coliform, okay? But basta it's a lactose fermenter, okay? So what you use is, again, you shake muna your water sample. Usually, di ba, katong ginabuhat ninyo sa katong butangan na nato diri is katong sa tanduay, right? So what we do is we invert figure of 8 mga 25 times within 7 seconds, okay? All right? Tapos, ayan, so that's your water sample. You put it in a vial, kuno, all right? And then after from there, you get 10 ml of the water, okay? All right, aseptically. So kato, flame the mouth of the container, tapos sterile na glass pipette by mukhaon, then aspirate. And then, flame na po the mouth of the test tube or the vial na naang broth, and then dispense. Ayan. 2 double-strength lactose broth. So, DSLB. So, double-strength lactose broth. So, di ba, na ay lactose. Because, as mentioned, coliforms, they ferment lactose. So, we're looking for organisms that ferment lactose. Okay? Alright. Ayan. So, DSLB. Okay? So, ayan. So, you distribute to 5 ka vials. So, each of them, butangan nimog 10 ml. And then, incubate at 35-37 degrees for 24 to 48 hours. Or if mugamit kang easy broth, you use at 45.5. Now, if mugamit kang easy broth, it's much more specific. Kaya you're looking lang jud for E. coli, right? Because it's easy broth. So, with the name of easy, ang point sa easy is dili Ethel Chapman, ha? Ang meaning sa easy is E. coli broth. Okay, so by the name itself, E. coli broth, you're really looking for E. coli na good. So, mas specific. Alright? Okay, so check the tubes for gas formation and of course for turbidity. If walay gas formation, we re-incubate for another 24 hours. And if wala pa Japon after 24 hours, then that's considered negative. Alright? So, ang positive yun na to, guys, is dapat na ay gas. Okay? So, again, if there is still no gas formation, after 48 hours, then that's considered to be negative na. Okay? Alright? If I'm not mistaken. Alright? Okay. Ayan. Ayan. Sige. Alright, so that's for the presumptive test. So presumptive pa lang, no? We're just detecting, again, all lactose fermenters, regardless, or all coliforms, regardless if it's fecal ba, regardless if it's gikan sa other sources. Okay? Alright. Ayan. Next, we have the confirmatory. So this time, we confirm na yun if the coliforms are of fecal origin. Okay? Alright. So what we do is, katumanga ni positive, turbidity and bubbles, no? We now gently shake. Ayan. So nanay mga bubbles. Alright? Alright? So usually, ma-detect kung ang bubbles mo siya, if positive siya, para makayon ka na, dili cause sa bubbles, or nagdili tungod, kay na-move ra ang tube muna nagka-bubbles. So, if it's really positive for fermentation, what you do is, i-try og shake a little ang bubbles, okay? If di gud siya mawala, then that's positive for fermentation. Or nagka-bubbles gud siya due to fermentation. Bahala, gamay ra na usara ka bula dira or something. Basta na ay bubbles or bubbles, regardless of pila sila kadaghan or unsa kadaghan or unsa kagamay, then that's considered positive. Okay, basta na ay bubbles. Pero if turbidity lang gani, then that means na dili siya positive because ang point magud nato lactose fermenters. So if turbidity ra, nitubo ra sila pero wala nila gigamit ang lactose. Gets? Kay nitubo ra sila sa broth, right? So, wala nila gigamit ang lactose because wala may gas formation. Okay, you know, in lactose fermentation, na ay gas na pwedeng ma-produce, di ba? And usually, E. coli is a rapid lactose fermenter. So, mo-produce po siya gas, di ba, in lactose fermentation. So, if turbidity ra, walay bubbles, then that's considered negative. Okay, so dapat na turbidity plus bubbles. Because the bubbles indicate that your organism is a lactose fermenter. It utilized lactose. Okay? Alright. Ayan. Okay, now with the sterile metal loop, we inoculate na po to brilliant green lactose bile broth. Now please take note, brilliant green, yan napan siya ay bile. So therefore, it's a much more specific, okay, and it's a much more selective na medium. Kaya na naman tayo mga inhibitors, brilliant green and bile, di ba? Remember? Okay? And then after, so kato mga na-positive, munto siya mong inoculate into the BGLB. Alright? And still incubate for 24 to 48 hours. And still the same, we check the tube for any gas. Gas pa rin, okay? Kay, naman siya po siya lactose. So, again, we're looking for lactose fermentation. That's when I bubbles. Alright, so, and if no gas is observed, still the same, we incubate for another 24 hours and re-examine for gas. And after 48 hours, if wala joy gas formation, then that's negative. Okay. Alright, okay. Ayan, next. For the completed test, usually this is not performed now. Okay? Not performed usually. Usually, kutob na daw sa brilliant green katong sa confirmatory. But next is sa confirmatory, so we perform the completed test. Now, again, this is done on positive na po na mga confirmatory tubes, confirmed tubes, to definitely establish the presence of coliform bacteria. So, what we do is, katong mga positive na green, sa BGLB, we streak to EMB, eosin, methylene blue, alright? Streak for isolation. So, ato na streaking is still MIS, no, multiple interrupted. Incubate and then observe for growth, okay? Observe for growth. Is it typical, nucleated, with or without metallic sheen? Atypical, opaque, nucleated, or mucoid. So, magbasa-basa ang colonies. Or negative, all others. Like all other colonial morphologies aside from nucleated, with or without metallic sheen. Okay, I'm not sure kung pasabot sa nucleated, but siguro kanang naay basta naay metallic sheen siguro. Same sa colonies sa imuhang E. coli on EMB and also your Enterobacter. Enterobacter, fish eye colonies on your EMB. Okay? Alright, so typical, atypical, or negative if different colonial morphology. Okay, and from there, kung nanay tubo sa EMB, mukuha tago sa ka-colony, alright? And then inoculate on NA, slant, nutrient agar, and then we gram stain the colony from the nutrient agar and perform IMVIC para ma-determine kung kinsa to na siya na coliform. Okay, but again, it's not routinely done unless gi-request gud siya, alright? Unless kanang kailangan gud siya for legal cases, example, kanang na outbreak of water something from a source, from a community source, yan ay mga legal actions na itabo or whatever. So, if kailangan siya na appeal completed, then i-perform siya. But again, it's not routinely done. Alright, okay. Ayan, so for completed test, again, your IMVIC, we follow now for IMVIC, still the same, organism, if E. coli, plus, plus, minus, minus. And for Kleb, or for Klebsiella or Enterobacter, negative, negative, plus, plus. And Citrobacter, negative, plus, negative, plus. So we will look for IMVIC because, again, these organisms are usually the indicators, diba, that coliforms are there, or fecal coliforms are there. Because, again, these organisms are fecal coliforms. Okay? Alright, ayan. So that's for MPN. So again, IMVIC profile, again, of some common coliforms. Okay, alright. Now, based on what we, from our results, no, we now refer to a table known as the MPN. So again, ang MPN index, MPN index, meaning again, the most probable number. So the most probable number, the density of bacteria na naa dito. Okay? Alright, so again, the calculated density can be obtained from the MPN table based on the number of tubes na atong number of positive tubes in the confirmed or completed. So sa confirmed, pila ka EC broth ang ni positive, or sa completed, pila ka broth pod if EC broth imong gigamit dito. So pila ka broth ang imong gigamit. Okay? Alright, ang ni positive. Ayan. So again, 0 less than 2.2. I'm not sure kung unsay iyahang unit, but 2.2 is the MPN, so density yun na sa kagaw na dito. Alright, so less than 2.2 per 100 ml. Alright, 1 is 2.2, 2 is 5.1, 3 is 9.2, and 4, 16. Kung 5 ang ni-positive, greater than 16. So usually, ang normal yun dapat is less than 2.2. So dapat 1 ra ang ni-positive out of the 5. Alright? And ang di na-acceptable is if maabot na siya 9.2. Alright? Okay, ayan. And kada different test setup, kani siya guys, kay katurin ng 5 ka-tubes na na-ay 10 ml each. But if na other setups, like atong 3 ml na 10 ml, di ba? Kato 3 tubes, there 3 tubes, niya, tulo ka setups, di ba? Or 5 tubes, tulo ka setups. They have their own MPN pod na table. Alright? So, kani siya is katong 5 ka-test tubes, niya 10 ml each. Kato atong gi-perform. Muni siya ang table na i-follow. Alright? But again, for other setups na ay different MPN indices. Okay. Alright. Ayan. Now, if we want to determine, Jude, if the coliforms are of fecal origin, no, we can also test it for fecal coliforms. Because again, as mentioned, diba, coliforms, they do not only come from fecal samples, but also may come from plant and soil samples. So some food and water standards, they specify the identification if the coliforms na detect sa imong water, are they of fecal origin or some other origin ba? So your fecal coliforms are thermotolerant and retain their fermentative characteristics at 44 to 45 degrees Celsius. And as mentioned, E. coli is the most predominant coliform. So that's why we perform that. So we inoculate a respective EC broth from the positive confirmatory tubes, di ba? Katong after confirmatory, instead of i-EMB nato siya, pwede siyang i-EC broth after. Okay? Ayan. Okay? And then incubate at 44 to 45 using water bath ba or normal incubator. And then check tubes for gas or bubble formation. So gas formation indicates the presence of fecal coliforms. But this test can be omitted or di na siya i-perform if katong sa presumptive palang daan nag-EC broth na ka or after confirmed test, di ba, nag-completed, nag-EMB ka, niya ang IMVIC profile kay consistent with E. coli or other fecal coliforms. Okay? So, pwede na siya i-omit or dili na siya i-perform. Again, if ang presumptive test nimo gagamit na ka og EC broth daan dito, or after completed, after confirmatory di ay nimo na test, katong after sa BGLB na broth, di ba? After na positive to dito, imong gi-streak sa EMB, niya gi-gram stain, di ba? Using NA slant, tapos nag-IMVIC ka. If ang IMVIC profiles ato are consistent with those of like E. coli, Kleb, mga fecal coliforms, then pwede na siyang dili mo perform ani. Okay? Alright. Ayan. Okay. Okay. So, for results, again, we determine qualitatively whether coliforms are present or not based on the confirmatory test. Okay? Determine the extent of pollution by estimating the coliform density, again, using the MPN table, and make a complete description of your result and final report of your water sample findings, like fecal coliforms have been detected or MPN of 2.2 ang nakitaan, so example. So again, coliforms, not more than 1 sample ang acceptable, okay? And may contain a coliform level lang of MPN of 2.2 per 100 ml. And no sample shall contain an MPN of 9.2 per 100 ml. So, dapat dili mula pa og 3 ka-samples ang ni-positive. So, dapat mga 1 lang jud ang acceptable. Ang 2 kay medyo, 2 tubes ang ni-positive, medyo carry pa, pero medyo ano na siya, borderline siguro. Pero dapat dito siya mula pa og 9.2. Alright? Okay, so that's for MPN. Most probable number, so you're just estimating or calculating the density of the bacteria that may be present in your water sample. So that's for the multiple tube fermentation test. So by name itself, we're looking for ability of the coliforms to ferment lactose. Okay? Alright, and we're really after for looking if asa bagikan ng coliforms are there of fecal origin, which would indicate na kung fecal origin siya, basin appeal po dito to mga pathogens from feces that may cause disease, or is it from other sources? Is it from soil ba or for plants? Okay? Alright, now for the next part of the video, we'll now talk about the other method for water bacteria, which is heterotrophic plate count. Okay? Until the end of the topic. Okay? Hopefully. Alright, okay, so I'll see you on the next video.